Hello, this is Dr. Nunez. This is the ACC 242 Exam 2 review. Exam 2 covers chapters 18 and 19. The exam has four problems. Let's get started with chapter 18. So, chapter 18, we looked at determining the allocation of factory overhead. And we looked at using a single rate to assign the overhead, departmental rates to assign the overhead, and activity rates to assign the overhead. Essentially, they all kind of work the same way. When we use a single rate, we take all the overhead. So it's total overhead in the numerator divided by some total allocation base in the denominator. So essentially, it's all the overhead over all the allocation base, whether the allocation base is direct labor hours or machine hours or something else. All the overhead over all the allocation base. When we use departmental rates, well, we take some measure of departmental overhead over some measure of the allocation base for the department. And we didn't have any problems where there were more than two departments. So in the case where you have two departments, it would look like this. We'd have the Department 1 overhead divided by the Department 1 allocation base, the Department 2 overhead divided by the Department 2 allocation base. So again, some measure of overhead over some measure of the allocation base. And we would be assigning or applying overhead twice using these departmental rates. And then activity rates, that means we have multiple rates. And we determine the appropriate activities, the cost for the activity, and then the activity base. And it's the cost divided by the base gives us the activity rate, and we'd have multiple rates. Once we determine the appropriate rate, whether it's a single rate, a departmental rate, or an activity rate, we would assign the overhead. And the assignment of overhead, well, it looks the same. It doesn't matter whether you have one rate, departmental rates, or activity rates. It's always going to be the overhead rate. Whether it's a single rate, departmental rates, or activity rates, it's going to be the rate times the actual allocation base or the activity. And if we want the overhead per unit, well, then we take the total overhead that we've assigned and just divide by the number of units. And there were several examples that we looked at from chapter 18, and I'm going to cover one of them that uses activity rates. In this first one, we have three activities. So the activities are defined. The activity base is defined. All we need to be able to do here is find the rates and then determine the overhead that should be allocated in total to each product and then on a per unit basis. So the way we find rates, again, is by taking some measure of the overhead divided some measure of the activity. And because we're using activity rates, well, the numerator is defined. We've got three activities, so three different costs, and divide by the appropriate activity base. Direct labor hours, and number of setups. So we want all the costs divided by all the activity. So for example, assembly has a cost of $105,000 and we're using direct labor hours, right? So assembly is the activity. We're using direct labor hours. We want all the hours, not just the hours for blenders or the hours for toaster ovens. We want all of the hours. So the way we get a rate is by taking that $105,000 divided by the 3,000 labor hours. 105,000 divided by the 3,000 labor hours gives us our activity rate. Same thing for testing. $39,000 is the cost of that activity, and we're using the 3,000 direct labor hours. 39,000 divided by the 3,000 direct labor hours gives us an activity rate of $13 per labor hour. And lastly, we've got $162,000 for setups. We want to divide by all of the setups, 180,000, 180 setups, and that gives us our rate of $900. So in part A, we find the rate, and these are all of the rates that we would use for the three activities. And then the next thing, we need to be able to find the total overhead that should be allocated to each product. The way we assign the overhead is by taking the rate times the activity. So we have our three rates, and then we have the activity for each product. So we know blenders use 750 labor hours. At 750, we're going to multiply times the 35. 2250 direct labor hours for testing, $13. 135 setups, $900. So the application of overhead, again, we're just going to take the rate, 35, 13, and 900, 35, 13, and 900 times the activity, right? The 750, 2250, and 135. 750, 2250, and 135. The rate times the activity gives us the assignment of overhead. So we're assigning the overhead three times for blenders. Put it all together, we add all that overhead, and that's total overhead. So we've assigned the overhead to the blenders, and we want to know the overhead on a per unit basis. Divide by the volume, the number of units, divide by the 7,500. So we divide by the 7,500 units and we end up with the overhead on a per unit basis, $23.60. We do the same thing for toaster ovens, right? We've got the rates and we've got the activity for toaster ovens, 2250, 750, and 45. So we're going to take the rates, 35, 13, and 900 times the 2250, 750, and 45. 2250, 750, and 45. That gives us the assignment of overhead for the toaster ovens. Add it all together, right? So we add all the overhead that we've assigned for this product, and we end up with total overhead. Divide by the number of units, right? Divide by the 7,500 units, and we end up with the overhead on a per unit basis. That's using activity-based costing. And again, it wouldn't matter whether we used one rate, two rates, or 15 rates. We'd be doing the same thing. Find the rate, some measure of overhead over some measure of the allocation base. Use that rate to assign the overhead, come up with total overhead, divide by the number of units. And then we move to chapter 19, support department and joint cost allocation. And this is kind of a multi-step process. And we'll look at the direct method. That's the only method that we covered in this chapter. And the way I approached the problems in class was to think of this first in terms of the support department. So find the support department and the cost driver that goes with that department. And then the usage for the support department. Find the appropriate percentage and then use the percentage to allocate the cost. And one of the examples we can look at here is exercise 19.1. We have the support department defined. So find the support department 1, the appropriate cost driver. It's just called cost driver. Find the usage of the cost driver, 1,500 and 200 and 300 for these three production departments, 1, 2, and 3. And then use the cost driver usage to come up with the percentages and allocate the 157,000. So down here, I've got that. Again, we've got the support department here. We've got the cost driver being defined, and then the usage of the cost drivers right here, right? So we have the usage of 1,500, the 200, the 300, all for a total of 2,000. And then we want the percentages. How do we get the percentages? 1,500 divided by 2,000. 1,500 divided by 2,000 is 0.75 or 75%. 200 divided by 2,000. 200 divided by 2,000 is 0.10 or 10%. And then 300 divided by 2,000. 300 divided by 2,000 is 0.15 or 15%. So that's our 100%. And we're going to use those percentages to allocate this 157,000. Multiply the percentage times the cost of 157. This is our allocation. That's the amount we'll allocate from the support department to production 1. And then 10% times 157 is the amount we'll allocate from the support department to the production department 2. And then 15% of that 157 will allocate 23,550 from the support department to production department 3. And we always want to add down to make sure we've allocated everything and we don't have a math error in there. So 100% those are the percentages to allocate that 157. That's the direct method, one support department. And then I also have here handout problem number one with two support departments. So here we have the janitorial and cafeteria departments and two production departments, cutting and assembly. So again, identify the appropriate support departments. They're here, right? Janitorial and cafeteria. The cost driver that goes with those support departments. Square footage goes with janitorial. Number of employees goes with cafeteria. And these are the costs that we have to allocate. And then we need usage of that cost driver. So the cutting department, here's the cutting department uses 2,000 square feet. Assembly uses 8,000 square feet. So we have usage of square feet and the number of employees. Cutting has 60 employees. Assembly has 20 employees. So we've got the usage of the two cost drivers, and we use the usage to get the percentages. So when we use the square footage for allocating out the janitorial department cost of 400,000, it's the 2,000 over 10,000. That's going to be 20% that we allocate of that 400,000 or $80,000. 8,000 out of 10,000 is 80% times that 400,000. We're going to allocate the 320. We've allocated the total $400,000 from the support department for janitorial to these two production departments. And then we do the same thing for cafeteria, right? 60 employees and 20 employees is a total of 80. 60 out of 80 is 75%. 20 out of 80 is 25%. And we're allocating out this 170,000. So multiply the percentage times the cost for the department. That's how much we're going to allocate to each department, all for a total of $170,000. So that's a couple of examples of the support department cost allocation using the direct method. In chapter 19, we also looked at joint cost allocation. So when we have joint costs, that means we've got, a single input or inputs that result in multiple products, and we need to be able to allocate the cost of those multiple products using some allocation method. We looked at two methods, the physical units method and the market value at split off method. Let's start with the market value at split off method. So again, it's kind of a multi-step process. We need to know what the physical units are, and then use those physical units to get the percentage, and then multiply the percentage times the joint cost to get the allocation. So in this first illustration, we've got three joint products, right? So again, you have this joint process that results in three products, right? And we need to be able to take this joint cost. This $1,500 is the joint cost, and it needs to be allocated to these three products based on the physical units, the pounds. So we use those pounds to get the percentages. So the sirloin, the ribeye, and the T-bone, we got the pounds, and then the percentages, 99 out of 220 is 45%. 55 out of 220 is 25. 66 out of 220 is 30. Multiply the percentages times the joint cost of 1,500, and that's the allocation of that joint cost. And again, you always want to make sure you add down so that you don't have any math errors. You want to ensure that you've allocated the entire amount of the joint cost. And your percentages, of course, always need to add to 100%. That's the physical units method of allocating the joint cost. An alternative to using the physical units method is the market value at split off method. So some companies prefer to use market value. The process is a lot like using the physical units method. Instead of allocating based on physical units, you just allocate based on market value. And you use market value to determine the percentages, and then multiply the percentage times the joint cost to get the allocation. So in this case, we have three products that occur in this joint process, all right? So again, you got one joint process, and in this process, you end up with three products. right? And you need to be able to of all, allocate the cost of $15,800 to all three of these products, to the gasoline, the diesel, and the kerosene. But we're going to use market value. So to determine the market value, we're going to take the physical quantity and multiply that physical quantity times the market value. And I've got a couple of typos here. So you should have gasoline, diesel, and kerosene. So if you just want to cross these out, sorry about that. So you should have the gasoline, the diesel, and the kerosene here. Right, so the physical quantities, I got those right. The 3415, the 2732, and the 1366. So the physical quantities are listed here, and you want to multiply times the market price, right? The $2, the dollar, and the $3. So the quantity times the price gives you the market value. And you want to do that for each of these three products. The quantity times the price gives you the market value. And then once you get that market value, you're going to use the market value to determine the percentage. So the 6830 divided by the 13660, that gives you 50%. And the 2732 divided by the 13660, that gives you the 20%. And then the 4098 divided by the 13660, that gives you the 30%. And you want to take the percentage, multiply times the joint cost, the 15,800, that gives you the joint cost allocation of 7,900. So again, the percentage times the joint product cost gives you the allocation of that joint cost. And you want to add down to make sure you've allocated the entire amount of the joint cost. And of course, make sure that you do have all your percentages adding down to 100%. And that's the joint cost allocation using the market value at split off. So we have in this chapter, again, the support department cost allocation using the direct method, and then the joint cost allocation using the physical units method, as well as the market value at split off method. And in chapter 18, activity-based costing, and we also have using a single rate, departmental rate, activity rates. Again, exam 2 has 4 problems. If you have any questions or concerns, don't hesitate to reach out to me. And good luck studying. See you at the exam. Make sure you have a pencil and a calculator. That's it.